first part of this session will be to solve the problems on tangential and normal coordinates for curvilinear motion. And as we said, guys, in the video lecture, AT, which is the tangential acceleration component, stands for the velocity change in magnitude or the speed change, while AN, which is the normal component of acceleration, it stands for the change in direction, because this is not a rectilinear motion, it's a curvilinear motion. And that's why, guys, in rectilinear motion, I don't have any AN. My acceleration will be only tangential, all right? I don't have any change in direction, all right? So this is rectilinear motion. I don't have a change in direction. Instead, I have only a change in magnitude, all right? And in the rectilinear motion, I don't have, or I have a radius of curvature that is equal to infinity. And that's why n is equal to 0 mathematically, because n is equal to v squared over rho. When rho goes to infinity, n will be equal to 0. So guys, this is for the first part in this session, which is about the curvilinear motion in tangential and normal components. If I want to solve the first problem here, which is example 10, I need to determine the maximum constant speed. So it's constant, right? So what does this term here mean, guys? Constant speed. Constant speed means what, guys? A is equal to 0, the whole A side. Yes, Ihab, yes, Hassan, it's AT is equal to 0. No, Ala, it's not AN. Okay, so Ala, we said that AN stands for the change in direction, while AT stands for the change in speed. So AT is equal to 0 because, in fact, the speed is constant here, right? So determine the maximum constant speed a race car can have if the acceleration of the car cannot exceed 7.5. So what does this mean, guys? They're giving me an acceleration. So this acceleration should be an, because, in fact, AT is equal to 0. So I need to find the velocity so that my acceleration cannot exceed 7.5 while rounding a track having a radius of curvature of 200. So I know the radius of curvature, which is here, which has a symbol of rho. All right, so this is a very trivial example because I know that A is equal to radical AN squared or AT squared. So usually they start by AT plus AN squared, and since AT is equal to 0, then this A will be, so this is equal to 0, then this A will be in fact AN, and they are telling me that this acceleration cannot exceed 7.5, so it's less than or equal to 7.5, and I know what is the equation of AN, guys? It's v squared over rho, yes. So it's v squared over the radius of curvature, and this should be less than or equal to 7.5. And this means, guys, that v squared should be less than or equal to 7.5 times rho, and rho is 200. And this means, guys, that v should be in magnitude, should be less than or equal to, I know here the value, it's less than or equal to 38.7 meters per second. I'm going to take V positive. Let's go back. So here they are talking about magnitude, all right? So they are saying what should be the maximum constant speed. And I know that the speed means magnitude. That's why I take it as positive. So in magnitude, V should be less than 38.7, all right? Example 12, the motorcycle is traveling at 40 meters per second. So this is the motorcycle at point A. It's traveling at 40 meters per second. If the speed is then decreased, so I have a decrease in the speed so that V dot is equal to minus 0.05 seconds. What is V dot? What is V dot, guys? Is this AT or AN? Yes, Hassan, this is AT because it stands for the variation of the speed. It stands for the variation of the speed. So AT is equal to minus 0.05 S. So it is in terms of S, all right, guys? Where S is in meters measured from A, right? So this is S. So it is measured from A means that at A, S is equal to equal to 0. Perfect. Okay, determine its speed and acceleration when it reaches B. So I need to determine its speed and acceleration reaching B. How can I do it, guys? How can I do it? Yes, I should use ADS is equal to VDV. So why did you choose this side? Why did you choose this equation? Because it's the equation that is independent of time. Yes, because V dot is given in terms of S. So I'm going to replace ET here by minus 0.05. Can I use this equation for AN? No, perfect. Because, guys, you should put on your mind that any equation used in rectilinear motion could be used in curvilinear motion, but you have to replace A by AT. Because, in fact, AT here stands for the change in velocity. I'm going to replace this by minus 0.05 V. Then I'm going to do the integration between what and what? What, guys? Between A and S. And here between VA and V. And that's why, guys, they gave me the speed at A. All right? Because if I don't know the speed at A, I cannot solve for this integration. So what's the integration of minus 0.05S? It's minus 0.05 S squared over 2, right? And it's between A and S, and I know that SA is equal to 0, right? So it's minus 0.05 S squared, and what's the integration of VdV, guys? It is V squared over 2 between A and V, right? So I'm gonna do it like this, minus VA, which is 40 squared, all right? So then I can remove this 2, and this means, guys, that V squared for any S is equal to minus 0.05 S squared plus 40 squared. You agree with me, guys? Do you have any questions so far? So this is V squared. Okay, now the question is to find this V, but at V. So how can I find this V? I should find S. All right, what is SB? What do you think, guys, is SB? What is SB, guys? What is SB? From math, from geometry, what is SB, guys? It's R times theta. Perfect, Hassan. Yes. Guys, if you take a look at this figure here, this is rho and this is rho. Between A and B, rho is constant, which means A and AB is a part of a circle having a radius that is equal to 150. All right? And I know, guys, if I have a circle, and if I have an angle at the center of the circle, so let's say this is theta, all right, then this arc right here, the measure of this arc right here should be R times theta. While theta, guys, theta should be in radians and not in degrees, all right? Because this is the measure of an arc, right? So this is a very important equation that could be used in this part of this chapter. So SAB, so I'm gonna say SAB will be equal to R, which is 150, times theta, which is 60 in degrees, all right? So what is theta in degrees? It is pi over 3. So this is SAB, guys. Okay? And then this means that V squared is equal to, will be equal to 983. Right? Now what about VB? So this is V squared. And what about VB? Let's do the square root of this value. So SQRT of nth is equal to 31. What do you think now the sign of VB? Right? Is it plus 31 or minus 31? Plus. Why side is at plus? Why is it plus? It's going up in the positive direction. So guys, this VB should be less than 40, all right? Because this is a decelerating motion. So this is 31 meters per second. Now, how can I find the acceleration? So let's find out what is the acceleration. What is A, guys? A is equal to radical h squared plus an squared. Okay? I know now AT because in fact I know S. So I know that AT is equal to 0 point or minus, all right, 0.5 times SAB, which is 150 times pi over 3, and this is squared. So it will be minus 7.85, this AT, plus AN squared. Now what is AN squared? What is AN squared, guys? AN is V squared over rho. And guys, don't get confused because students can have this mistake. They put instead of AN squared, V squared over rho. All right? No, it's V squared over rho squared. So don't forget this power 2 here. Now I know VB squared, in fact. And I know rho, which is 150. So I can find A, right? So A could be 5. So if I have a circle right here, and I need to find this arc, I don't know the angle from the center, but I know the angle, let's say, with this tangent here, or this tangent here, it's the same. This is ds. In fact, guys, this is r theta over 2. Right? So if you remember from geometry, if the angle is given with this tangent, it should be this S will be r theta over 2 and not r theta. So if this angle is given at the center, it will be r theta. If this angle is given with a chord here, so this will be r theta over 2. Okay? So this S will be r theta over 2. All right, guys? All right. Are you done, guys? No, I'm not. Because if the question is to determine, I need to determine the vector A. All right. So as a first step, I can find the magnitude of A. But how to find A in vector? I should find also the angle of A with, let's say, a fixed vector like I. All right. So don't forget, guys, if I know, let's say this is B, I know AT, which is negative, and that's why I put it in the opposite direction. And I know AN. I need to find, let's say, the angle that this A is doing with one of these vectors. Let's say I need to find this angle here. How to find this angle, guys? Tan theta will be equal to AN over AT. Okay, guys? Or you can find this one here. So you're going to say it's AN over AT. It's AT over AN. So you should specify the angle and the width, like we did, guys, in statics, in order to find or in order to determine a vector. So In order to determine a factor, you should put the magnitude of this factor as well as the angle. Okay?